Hello, good evening, everyone.
Good evening.
Hello, good evening.
Uh,
Hello,
yeah, hello. Have you gone through yesterday's session, day before session, everyone? We have discussed on comparison between system Verilog test bench and UVM test bench, right? Did you all understand the overview about the UVM test bench?
Yes, Prashanti.
Okay. Any other doubts? No
So,
doubts, huh? Okay, fine. So let me know if you have any doubts. I think everyone got clarity about system Verilog test bench architecture, right? So what are the different components will be there, like sequencer, difference between sequence item, sequencer, driver, monitor, scoreboard, interface, agent, and environment, test bench top. So today onwards, we are going to discuss each topic, internal topics, one by one. Okay. First of all, we will start with verification components. Components all completed. Test bench hierarchy completed. So class libraries, we will discuss with the class libraries and okay. First, we will start with the class libraries. So first of all, you already know, right, what is meant by UVM. Is the screen visible? Presentation?
yes, yes.
Okay. So in System Verilog, we don't have any class libraries. Whatever we have created, generator or monitor, whatever the driver, we never extend from the parent class. The generator driver itself, those are the parent class. If you want to extend with child class, we will create some more classes. Okay. But in UVM, everything we will extend from the class library. Okay, by default, we have everything in a predefined libraries. So if you want to create something UVM sequence or UVM driver, we will extend from the parent class, which already the functionality, actual functionality present in the class library, in the parent class library. So UVM, I already shown the example. UVM driver extends from the UVM driver. I mean, the class driver extend from the UVM driver, or basic sequence extend from the UVM sequence, and we need to pass the parameter like that. Okay, so the UVM library provides all building blocks that we require to build modular, scalable, reusable verification environments. This library contains all base classes, utilities, macros. Okay, utilities in the sense same as a macros. While we are creating a class or a object, we have used tick UVM util object, tick UVM util componental. Okay, those we call as a utilities or macros to support the entire verification process. All these things comes under library. Okay, and in order to use UVM library, user need to compile UVM package.sv file. Everything will be there in the UVM package.sv. Okay, in every top module, we need to include this library. We need to import UVM package into the desired scope, include all files that contain UVM macros. That means in that package, all the macros or UVM libraries, everything predefined in that. Okay, so I can show you. See here in testbench.sv top level, actually in system verilog we include only interface.sv and test.sv in the testbench top level. Okay, that is the main top level. But in verilog HDL we need to import this second line. If you observe, import UVM pkg scope resolution operator star. That means UVM package we are importing here. So if you don't use this line, whatever we written here in the sequence, if you see here macro UVM object utils macro, or in driver we use the UVM component utils macro, fourth line. So all these things we cannot call directly. And also if you see here class driver extends UVM driver. UVM driver is a predefined class. It's a parent class. Okay, already the built-in library functionality, everything there in the UVM driver. Okay, whenever you don't import this UVM package, we cannot use all those macros. Okay, so that's why this package is very important. And UVM macros.svh related to macro files, everything will be there in this UVM macros.svh. These are all predefined libraries we need to include while we are writing the program. In the top level we need to include. Okay, so include UVM package, include file that contains UVM macros. And next example, hello world. Like here how I just shown you, right, how UVM package is including and the import is package is importing. And just a small example, module hello world initial, tick UVM info, some UVM statement. Okay, and coming to the UVM library, so how all the base classes are called here. Okay, in UVM we have lot of methods like a copy, compare, clone, print. There will be lot of methods. Okay, so how the methods will be accessed here? First of all, the execution, flow of execution. Okay, so every time the data will be executed from UVM void. UVM void is the top level. It's a top level class. Okay, it doesn't contain anything, but we need to run everything from the UVM void. And UVM object. So in UVM object, predefined methods will be there, like a copy, print, compare, clone. All these methods will be there. So if you want to use all those methods, we need to make the registration. That's what we call as a factory registration. If you don't use factory registration, you cannot use these type of methods. Okay, and in the objects, I already told you, right, in UVM we have all the components, driver, monitor, scoreboard, environment, all these are components. But the transaction, sequence items, sequence, all these are objects. Okay, if you see here, um, sequence item. So class sequence item extends UVM sequence item. So while we are creating this class, we are writing it as an object, UVM object utils, because sequence item is an object. And also sequence is also a object. Add sequence, it's an object. Okay, so in the object these are derived. Like the driver is a component, so here we will write as a UVM component utils. Monitor is also a component, that's why we create it as a component. And agent, scoreboard, all these are components. Okay, next, UVM component all faces. In the components we will put all the faces. If you observe, in the object we never put the faces. So in the sequence item we don't write any faces. In the sequence we don't write any faces. In sequencer also we don't write any faces. But in driver we write all the faces. Built-in face, run face. Yesterday I already told you, right, why do we use the faces? So time slots for everything we are putting some time slot to create or to connect or to run the main functionality. Everything will be written in the particular time slots. That's what we are calling as a phases. Okay, so for components only we write the phases: driver, monitor, and scoreboard, agent, environment, all these we have in phases concepts. Okay, and next, UVM component, UVM test, UVM environment, all these, all the components, monitor, driver, scoreboard, all these things will come under components. Okay, this is what the flow of execution. And next, features of base classes. What are the base classes? UVM void class is a base class for all UVM classes. So here UVM void is a base class for all classes. It is an abstract class with no data, members or functions. As it you see the name called void. Void means it doesn't have anything, but it's just a base class to all. Okay, and UVM object. UVM object class is a base class of all UVM data and hierarchical classes. It defines set of methods of common operations such as a create, copy, compare, print, whatever I explained, same. Okay. And what is UVM transaction, UVM report object, reporting mechanism to print all the messages like info statements, error statements, fatal error statements, warning statements. All these things comes under UVM report object reporting. Report in the sense the same as a display statement, but we use here as a info statements. UVM info macro, UVM warning macros, everything we write in terms of macros only. Okay. And next, UVM component. UVM component is the base class of all UVM components. Components are quasi-static objects that exist throughout the simulations. And this is all this called this class inherits features from both UVM object and also UVM report object. Hierarchy first we write the hierarchy, phasing, configuration, factoring. All these are different concepts. Okay. And next, coming to the UVM object.
Prashanti,
Yeah,
what is the meaning of quasi-static?
where it is.
It was in components, UVM components first slide.
Components.
Components are quasi-static objects. Quasi in the sense it's a duality we call. It's like a static objects. It's same meaning as a static objects where we cannot change.
Okay,
Yeah.
okay, okay.
Any other doubts, others? Okay. So UVM
Components
object.
will be available after this build phase or connect phase one.
Connect phase. In the build phase, we just create the component. We don't connect the component. Suppose create the component in the sense just we put the sequence, sequencer, driver, monitor. Just we will create like this. Okay. In the connect phase, we make the connections between these two, like using the TLM port, monitor to scoreboard, monitor to coverage, monitor to checker, or monitor to RAL model. We make the connections in the connect phase. In the run phase, we run the data like sequencer to passing the data. In sequencer, we don't have the phases concept. Why? Because those are the objects, right? In sequences. From driver to DUT, we need to pass the functionality, right? Driving the data. So that that thing will be happened in the run phase.
Okay.
Okay. So coming to the UVM objects, following are important methods defined inside the UVM object. First of all, new. You already know what is meant by new method. Set name, set or override the instance name, get and set method. Same as mailbox and get full name. Just it return the full hierarchical name of the object. Okay. And next, object methods. In UVM, we use a
So,
new.
sorry to interrupt. There's
Yeah.
a person on the group, Vinita Singh. She's not able to join. She's written on WhatsApp group.
Okay, let me check. But it's not showing here. Okay, fine, we'll see. So here object methods, these are the object methods, and to create the object, mostly in system verilog we use a new method to create a mailbox or semaphore or any object or any class. Mostly we use the new method, but in verilog hdl we never use new method. Here we use a create method. Why? Because by using the create method we can recreate or override the data. Okay, in UVM by using the create method, we can override the data type anytime. Okay, so override the data type, you will face one difficulty in system verilog. We already seen the example of FIFO memory, right? So in FIFO memory, here we have created n number of test benches, test cases, right? In the generator, three transactions we have created: transaction 1, transaction T1, transaction T2. And here in the transaction class, we have written three types of constraints. So write is equal to 1, read is equal to 0, and for write case, and for read case, and for rand 1 case. Okay. So for these transactions, we have created the three transaction instances and created three number of times. But in the test top level, how we are running those test three transactions, we need to call the three number of transactions. So here we are writing dollar test dollar plus arg. Have you observed this thing? Anyone? Why we are using this thing here? For T1 and for T2, dollar test dollar plus argument, and here for T3, dollar test dollar plus argument. Have you observed that?
Maybe we're trying to add this argument in the logs. Maybe. I'm just guessing.
In the logs. Okay. Here we are not taking any log file like that. Just how the test will be run here. Here we
We are
have
getting the
taken
argument from the run command.
no. In Verilog, we can avoid this problem by using factory override concept. But what is this? What is the usage?
I think no idea. Can you explain?
I already explained in System Verilog about this. It just enable the debug messages, test $test plus argument. So while we are enabling or disabling, whenever we are writing some debugging logs, for that purpose we use test plus argument. So how we can avoid for if we write overriding concept, so without writing this, how can we avoid? No idea. Okay, once go through this concept, it's a very big concept. In factory registration time, I will explain you clearly. Okay, as of now, not required. So once from your side, once try why we are getting these dollars simulator and also how we can avoid that thing. Okay, so here we are using the create concept. Create method is used for overriding the data type. Same here. We are taking the three number of times the data type we are considering three number of times. Okay, so without changing those many number of times, we can directly use the create method so that every time the object name or the data type name we can avoid easily. Okay, by using just a create method. That's what we call as a factory override concept. Okay, so here how do we use the create method means in the build phase. In the build phase, I told right, we just create a sequencer or driver or generator monitor. So in the build phase, we use this create method, creating all the components or objects. Okay, and next class my object extending from UVM object. Here we are using create method and creating the object name and return the object and function and class. Okay, that is one of the method in UVM. And next to copy method. Copy method you already know in system verilog we have static copy and deep copy. Okay, but what is the difference between static copy and deep copy? Just the memory is different. Memory allocation will be different. Okay, so here in UVM we don't have those things, static copy or deep copy. We don't need to write extra functionality and all. Just we use a copy method or clone method. Clone means create plus copy. Okay, or create method, print method. These are the methods directly we use in the classes. Okay, so to use these methods, we need to register the class or an object. That's why we are writing as a util macro here. Pick UVM component util. So whenever we register with this macro, we are able to access all these component, all these objects. Okay, so by writing that we can access all the components and methods here. Okay, next thing example. So how we are using the methods in this example. Just creating the data, address, direction, and some delay. And UVM factory. See here, object. Here, class mem transaction is a object. So that's why we are using tick UVM object utils begin, end. I already told, right? Whenever there are multiple number of statements within that, we need to use a begin end. So that's why here we are using utils begin and utils end. So for which class we are creating this object for mem transaction. So here mem transaction. Okay. Next, take UVM field int. I already told data or this address or direction delay. All these things will come under the int data type or enum data type. Okay, bit, byte, all these things comes under int data type. So that's why we directly put as a int. Okay. Next, UVM default. UVM default in the sense we are activating all the methods directly to here. Okay, we have different types of methods: copy, compare, clone, print. These are different methods we have. That means default all the methods it can use. Okay, and here also UVM default all the methods it can access, and here also all methods it can access. But next, UVM default or UVM no compare. That means it cannot access for compare method, no compare. So it cannot do comparison. It cannot access the compare method. Instead of that, it can use all the methods. Okay, you can copy or you can create or print method. All these methods, there are a list of methods are there. So whatever the methods are there, we can use every method by using UVM default. We are providing the access. Okay. Next, class constructor. You already know what is the use of class constructor, assigning the memory to the particular object. Okay, these utils are just to access the registration, to access the overriding concept. Okay, and to access all do hook methods. Do hook methods means these do compare, do copy, do clone, do print. All these methods are do copy methods, do hook methods. Okay. Next, within the module top, import UVM package, UVM macros, transaction, all we are including, and A1 is equal to, A1 is the object, so creating. So here is the create method, and that is what example 1. Next thing is example 2. So how we are doing the randomization and how we are creating second object transaction A2 dot of copy of A1, copy method. Here we are using copy method, and next clone method A3 comma A1 dot clone. Next A3 dot compare of A2, not, if both are not equal, UVM error. Okay, so this is how we can use the different methods. Okay, in the coming in the next session onwards, we are going to work on the lab sessions also. So today overall I am going to discuss the theory part. Okay, so this is how we use the all methods in classes. Next, this is how the printing, print in the sense UVM, here we have used the macro UVM error to print the fail statement. Like that, A1 dot print method, A2 dot print, default line printer, A3 dot print. So here instead of $display, we use the print methods. Or if any fatal errors or any UVM errors, we use fatal statements or UVM error statements or UVM warning statements. Like that, warnings and fatal errors automatically the list it will generate. No need to write separately. So result will be given in this. In result, however, it is printing the table here. In that also we'll have lot of models in the reporting mechanism, like printing in a tree model or in a table manner or in a hierarchy manner. There will be lot of ways. Okay, we need to select any of them. So see here, tree printer, here table printer, and here print tree type, tree printer. Next, line printer. All the things we can print in the line printer. Okay, so these all are different type of examples, simple examples. And any doubts still here? Anyone?